Hello back. I'm sorry. There was an internet disconnection over here. For that reason, I was cut off in the middle of this video. So we continue our lesson for section. Just to keep you, just to remind you where we are. We are in section 2.5. The chain rule. We are studying the chain rule. And so far, we saw that we are dealing with the composition of two functions, and the technique to take their derivative is chain rule. So we also saw what is the chain rule, and now we are doing the first example. The first example to see how to apply chain rule to take the derivative. Okay, so let's continue working on this example. The example is sine of x squared. And the question is, what is the derivative? What is the derivative of sine of x squared? Since sine of x squared is a composition of two functions, so we can use chain rule. First, let's see what is the composition here. So here, the first function takes the input value of x and then return us in terms of calculation. When you substitute a value for x, the first calculation is x squared, right? So you give the input value of x, and then the first function calculate the x squared. So the first function here is x squared. Whatever you give to this function, it make it square. And then the next function comes and take this as the take this value as the input value. What is the calculation in the second step? It calculates the sine, right? So it takes the square and it gives us back the sine of this input value. So the second function here is sine. So the second function in this calculation, we can call it f. You can give it any name that you want. Let's call this f. So the function f is just function sine, the sine function. Okay, so one more time. We are composing to sine of x squared. In fact, is the composition of two functions. What two functions? X squared, which is power function. So here you have a power function. And then the next function is a trig function. Okay, so it's a composition of a power function and trig function. Okay, now let's take the derivative. Let's apply the chain rule. What does chain rule says? So let me first rewrite this composition. So sine of x squared, c of x, which is sine of x squared, is in fact f of, because sine is f in my notation, f of g of x, right? F of g of x. Again, f is sine of x, g is x squared. Okay, now we can apply chain rule. Now let's apply the chain rule. Chain rule. What does chain rule says? It says if you have a composition of two functions, then the derivative, it says derivative of this composition is gonna be derivative of the first function, so g prime of x, multiplied by derivative of the second function, f of, but at its input value, which is g of x. That's what the chain rule says. Okay, so let's just, sorry, derivative. I forgot to put the notation, the prime notation. Derivative. So derivative of the first function, g of x, and then the derivative of the second function at this input value. So it's gonna be, okay, if you want, you can also calculate those derivative. What is the derivative of x squared? It's 2x. So you can say this is gonna be 2x times. What is the derivative of f? It's cosine, right? Because when f is sine, the derivative is cosine. So it's gonna be cosine of, what is g of x? G of x is x squared. So cosine of x squared. That